Breaking news. SpaceX's Starship Flight 10 faces a critical hurdle, not in the sky, but on the launch pad. A damaged booster quick disconnect threatens to delay Elon Musk's ambitious 3-week launch cadence. Join Starship mission updates as we uncover the scorched QD's secrets, explore Launchpad B's game-changing upgrades, and reveal how SpaceX is building the future of interplanetary flight. Don't miss this pivotal moment. New images reveal that the booster quick disconnect, arguably the most sensitive and complex part of the Starship launch pad, suffered damage during the recent liftoff. The QD is visibly scorched, not just on its outer shell, but deep into its internal components. Some areas show signs of breakage, and the edges and joints of the shell appear partially melted. If a robust system like the QD can be damaged, then it's reasonable to assume that more fragile systems, such as fuel pipes and smaller ground connections possibly located farther away, may also have been impacted. In fact, back during Flight 3, there were signs that fuel lines might have been severed due to the enormous force exerted at launch. So what caused this new damage? Looking back at the launch, the engine burn lasted around 15 seconds before the energy plume fully cleared the pad. During that time, the launch pad, especially the booster QD, was exposed to unimaginable heat, pressure, and acoustic energy from the combined power of 33 Raptor engines, producing the most powerful rocket thrust in history. The booster QD is especially vulnerable because it sits just beneath the Super Heavy booster and remains physically connected to it until the moment of liftoff. As the launch clamps retract and the rocket begins to ascend, the QD system must simultaneously disconnect all fuel and electrical connections and seal itself shut to protect its internal systems. However, there's a chance that during this last flight, the QD didn't close fast enough. The timing mechanism, which coordinates the internal system retractions with the protective shell's closure, may have failed to completely shield the internal components. This could explain the warping and minor melting now visible around the edges and seams. Even when functioning correctly, the QD shell has limits. Its job is to resist intense forces for a brief window of time. But nothing lasts forever under that kind of stress. Even small gaps in the shell can allow high-velocity energy and heat to penetrate, damaging the sensitive systems inside. Now, with visible signs of wear and tear, SpaceX is likely facing the need for major reinforcement or even complete replacement of several components. Naturally, this has implications for the next flight. The launch pad is responsible for a critical step, the static fire test. Without a functioning QD system, this test cannot proceed. The next booster, P-16, has already completed its cryogenic testing and is likely fitted with engines, making it fully prepped for a static fire. But without a healthy launch pad, P-16 remains grounded. Every delay compounds the next. Looking further ahead, this kind of issue could make future launches riskier. If damage to the QD system isn't thoroughly repaired, it might compromise the takeoff process or, worse, suffer a catastrophic failure. Even in a best-case scenario, deeper damage will demand a longer refurbishment period between launches, slowing SpaceX's rapid development goals. So, will this booster QD issue delay Flight 10? That's the big question. SpaceX is known for solving problems quickly, but time is tight and the pressure is on. One thing is clear: while the sky may be the limit, the ground infrastructure, especially the launch pad, remains a critical part of the equation. After a dramatic and highly anticipated flight, Elon Musk's announcement that the next Starship launch could occur in just 3 to 4 weeks has generated widespread excitement. But turning that optimistic timeline into reality presents more than a few challenges. While the booster issues from Flight 9 have already been cleared by the Federal Aviation Administration, a new complication has emerged. Debris from the booster has recently been discovered, significantly increasing SpaceX's workload. On top of that, the spacecraft portion, referred to simply as the ship, is undergoing extensive investigation, which could further delay progress. But here's something not everyone is talking about: The launch pad itself, a system that usually fades into the background, has encountered serious issues in recent flights. Upgrades to the pad have worked so well that most people assumed it was no longer a concern. But it's time to take a closer look. And that brings us to the importance of Launchpad B, a major leap forward in SpaceX's infrastructure and long-term strategy. It's clear by now that simply patching or replacing damaged components after each flight isn't a sustainable solution. If Starship is to fly frequently and reliably, SpaceX must move beyond reactive repairs and toward a more robust, future-proof design. That's exactly what they're doing with Pad B. Unlike Pad A, Pad B features a groundbreaking change. The launch pad is no longer a single fixed structure that combines the orbital launch mount and booster quick disconnect. Instead, these systems have been separated and rebuilt as independent components. The new OM at Pad B resembles a modular mobile platform. It contains only the hold-down clamp arms, now protected by an upgraded opening and closing mechanism designed to shield the sensitive parts during liftoff. This change alone greatly enhances system durability and serviceability. Meanwhile, the booster QD has been entirely separated from the OM and constructed as an independent structure. It's housed within a prominent triangular steel frame, dubbed the BQD gantry, positioned right next to the flame trench. Recently, SpaceX lifted the new QD cover into place, confirming that the QD system now functions independently of the launch platform. This new configuration brings several significant advantages. By physically distancing the booster QD from the main OM and enhancing its retraction mechanism, the system becomes more resistant to the extreme forces of a launch or test. That means fewer chances of damage, quicker post-flight refurbishments, and minimal disruptions to other pad operations. These benefits are further amplified by the integration of a flame trench. This trench directs heat and pressure away from the pad and its most sensitive systems, preventing the accumulation of destructive energy. This is especially critical for protecting the booster QD, which suffered damage during Flight 9 due to exposure to intense thermal and acoustic loads. All these upgrades represent a significant step toward building the launch infrastructure of Starship's future. In fact, the same design is already being implemented at SpaceX's Florida site. This new pad, expected to be operational by the end of the year, will support an aggressive launch schedule, up to 44 launches annually. It's also slated to handle key NASA missions, including Starship flights for the Artemis moon landings. All this points to a clear and ambitious vision. SpaceX is preparing Starship for a high-cadence, long-term operational future. That future will demand launch infrastructure capable of supporting rapid turnaround times, something only possible with robust, easily maintainable systems. This isn't just talk. Musk has said that eventually a super heavy booster could launch every hour, while Starships could launch daily. President Gwynne Shotwell has projected up to 400 Starship flights between 2025 and 2028. Musk himself has outlined plans for up to 10 daily launches during each Mars transfer window, an unprecedented cadence in spaceflight. Even in the near term, 2026 is expected to see a rapid increase in launch frequency. The deployment of the Starship refueling system will require multiple Starship tankers flying in succession to fuel a single main Starship on its way to the Moon or Mars. These increases won't just be about quantity. SpaceX is also ramping up power. While Starship currently uses V1 and V2 versions of Super Heavy and Ship, there are already signs of the next evolution, version 3. This upgraded Starship will incorporate the more powerful Raptor 3 engines, increasing thrust and performance. As this hardware gets more capable, the ground systems must keep up, with Pad B leading the way and Pad A soon to follow. SpaceX is building a resilient foundation for the future of interplanetary flight. So this isn't just an upgrade, it's a transformation. Before SpaceX can fully realize its bold vision for the future of spaceflight, it must first overcome the immediate challenges ahead. At the forefront is the urgent need to resolve the issues with Launch Pad A especially the damage sustained by the booster quick disconnect. If SpaceX hopes to maintain its ambitious timeline and achieve a launch by June, repairs on Pad A must be completed within the first week of the month. This tight deadline is essential to ensure the site is ready to receive vehicle prototypes, conduct vital testing, and progress quickly toward the next phases of the launch campaign. But the challenges don't end with Flight 10. According to Musk, the next 3 flights could take place with a cadence of 1 launch every 3 to 4 weeks. This rapid pace would place significant pressure on the aging infrastructure at Pad A, which is still awaiting its major upgrade. While the FAA has granted approval for up to 25 Starship flights at Starbase, this goal will push Pad A to its limits, especially given its current condition. At the same time, Pad B must be completed and prepared for operation as soon as possible. The installation phase needs to be wrapped up to allow for full-scale system testing and validation. If SpaceX can bring Pad B online before Pad A is temporarily shut down for refurbishment, it'll ensure continuity in Starship's development. In fact, it's likely we'll see both pads operating together soon, with Pad B potentially supporting critical missions, such as the first attempt to capture both stages during flight, a major milestone for full system reusability. On the vehicle side, upcoming missions must tackle key technical goals. This includes completing unproven maneuvers, solving problems that arose during previous flights, and demonstrating increasingly complex flight profiles. Each successful step will pave the way for even greater achievements, such as catching the returning ship, implementing full reusability, and building the propellant transfer infrastructure needed for lunar and interplanetary missions. Clearly, the Starship program's path forward is filled with challenges. Issues can and do emerge from unexpected places, like the booster QD. While such setbacks can slow progress, they also serve as important reminders. Even in the midst of rapid innovation, SpaceX must remain vigilant, methodical, and detail-oriented. The booster QD incident is just one example, a single component in Starship's massive, intricate launch system. But it underscores a broader truth. To succeed on the road to space, SpaceX must continually refine, improve, and adapt. It's a monumental task, but not an impossible one. Now all eyes are on how SpaceX tackles this first hurdle on the road to Flight 10. The fix at Pad A will be the next proving ground, not just for hardware, but for the company's ability to maintain momentum in the face of setbacks. With determination, innovation, and a relentless drive, SpaceX will keep pushing forward, one launch at a time. This has been Starship Mission Updates. What do you think? Will the booster QD issue delay the next launch? Respond with yes or no in the comment section below. And don't forget to like the video and subscribe for more updates as we follow SpaceX's incredible journey to the moon and beyond. Thank you so much for watching, and always remember, curiosity, imagination, and inspiration will follow you so long as you keep looking up.